Hello, today I'll be presenting an operations and supply chain analysis that compares two industries that at first glance seems to have very little in common. The industries are automotive manufacturing industry, specifically the smart cars, and the fast fashion sector represented by brands like Zara and H&M. While one industry produces complex vehicles and the other produces seasonal apparel, we'll find that both face a very similar fundamental challenge, that is, how to provide a high degree of variety and responsiveness to a demanding market while simultaneously managing the costs. In this presentation, I'll explore the innovative strategies each has employed to solve its core operational problem. Let's begin by examining the smart car's supply chain design. Its network is renowned for a model called vertical collocation. As we can see from this diagram, this is a model where key system partners or suppliers are located on the same production site as the final car assembly. The diagram shows the central assembly line with the suppliers for major modules plugged directly into it. For example, we see the Bosch supplying the front axle, Magna supplying the doors, and Faurecia supplying the seats. This arrangement is a deep form of relationship purchasing, a level of commitment that is necessary for the supply of complex and critical parts. At the Smartwile plant, these suppliers deliver entire pre-assembled modules like the cockpit or doors directly to the assembly line just in sequence. This integration is also financial. As the text notes, payment to the suppliers is reportedly triggered only when a finished car is completed and rolls out of the assembly line. This extreme closeness provides significant technical advantages and makes rapid improvements much easier to implement. Alright, now I'll continue to look at the smart car's inventory and its decoupling point. Because of that smart while setup, a very specific inventory model can be used. The production model is defined as make to order, which is a pull system. In simple terms, this means a car is not built until a customer has already ordered it. This system uses just-in-time methods to cut waste. With suppliers located right on site, their parts are delivered just in sequence. That means if my specific car is next on the line, the parts for my car arrive at the line at that exact second. As a result, inventory is kept at a minimum. This diagram here on the left top shows the decoupling point. This is just the spot where the system switches from a guessing to a reacting system, which is from a forecast driven to a order driven system. For the smart car, this point is pushed very far upstream. The lean part is just the supplier stocking raw materials. The moment my order is placed, the entire assembly process it as pulled. First, this system is incredibly fragile without having any backups. If even one supplier's factory has a problem, the entire Smartwell assembly line stops cold. There is no buffer. Secondly, in my opinion, the IT systems holding this together must be monumental. My order for a blue car with the specific seats has to be sent to all the 12 suppliers at the same time, and they all have to make and deliver their parts in the exact same order. This is a massive and a complex information sharing job. Finally, this model can't be easily copied. It is a greenfield solution. It had to be built from the ground up all at once. An older company can't just decide to do this. Now I'm going to pivot to fast fashion. This industry faces a similar need for speed, but for different reasons. The focus here is on innovative products. This is just a term for trendy clothes that have highly volatile demand and a very short product life cycles. Because of this, an agile supply chain is required, one built for speed and flexibility. This creates what the slide calls fast fashion's dilemma. If you look at the scales, the problem is clear. A core dilemma is faced by these brands. Customers demand low prices, which requires cost efficiency, but this is in direct conflict with the need for speed and flexibility to make high variety of new clothes. This dilemma is purely about business. It completely ignores the sustainability dilemma. This high speed, low cost model has a massive environmental and social cost that isn't being shown on these scales. Secondly, this fast model is a brilliant way to solve a classic supply chain problem, the bullwhip effect. In older systems, a small change in the store sales would get magnified by every step in the chain, leading to a huge over-ordering. This agile model reads real-time sales data and doesn't guess. And thirdly, this whole system runs on data. It can't work without a constant, high-speed flow of information from the cash register right back to the design team. So, how is this dilemma solved? I'll show you from this slide how different bands have chosen very different paths to address this. First, let's look at H&M. A push system is used for basic items. This means large orders are placed for things like t-shirts to get cost efficiency. But this is a big risk. If the company guesses wrong on basic colors, it's left with millions of unsold items. For its trendier clothes, a more flexible pull system is used. Next, Zara. An extreme pull system is used here with minimal inventory and small batches. Their secret weapon is postponement. Fabrics are often purchased undyed. The color decision is made at the last possible minute. This gives them incredible speed and flexibility. Zara's speed isn't just from dyeing, it is also from high vertical integration. This means Zara owns its factories in Spain. This nearshoring gives them total control and speed. H&M, by contrast, leverages a large global network. It outsources its production, which is cheaper but much slower. Finally, Benetton. Form postponement is also main strategy here, but it's done differently. Garments are dyed after they are assembled. This maximizes the chances of meeting color demands. It is a very clever solution, but it should be noted that dyeing a finished, assembled piece of clothing is technically very difficult and expensive. This table brings in all the points together discussed in this presentation. A leagile approach is used both by the smart car and fast fashion industries. This just means they mix lean and agile ideas. But how they mix them is totally different. To me, the most important row is physical integration. This term is used to describe three completely different business models. Smart cars, radical vertical collocation is used. This is supplier integration. Partners are invited to build on the same site. Zara, high vertical integration in Spain is used. This is self-integration. The company owns its own factories. Thirdly, H&M, extensive outsourcing globally is used. This is a networked model where the production is managed across around 750 suppliers. This physical setup, in my analysis, controls everything else. It explains why a strong pull system can be used for the smart cars and an extreme pull-based model can be used for Zara. They have high physical control. It also explains why a mixed push-pull system is used by H&M. The outsourced network is too slow for a pure pull model. And it explains inventory slack. Minimal inventory is possible for smart cars, just 12 partly assembled models, and Zara because they are fast. H&M's optimized for volume inventory is necessary buffer to deal with its slow global supply chain. So, what is the conclusion from all of this? Both the car and the fast fashion sectors show that a leagile supply chain strategy is necessary to manage the trade-offs between efficiency and responsiveness. The most critical takeaway for me is this: there is no single best supply chain. The best system is the one that is perfectly built to solve the company's main problem. The smart car system was built to handle high product complexity, while the fast fashion systems are built to handle high demand volatility, that is, unpredictable customers. Both are leagile, but they are leagile in a very completely different ways, and each custom fit to the problem it needs to solve. Thank you.